All right, so we are back, and today we're going to be solving equations with variables on both sides. Okay, so we've got this equation, 7n minus 2 equals 5n plus 6. So we've got that n on both sides of my equal sign. So in order to solve, we're going to need to collect the variable terms on one side of the equation. So, as a hint, I am suggesting that equations are often easier to solve when the variable has a positive coefficient. We've seen how we've gone a little astray when we've had negatives in front of things. So let's try to keep them positive whenever possible. So we can move this 5n over to here, or we could have moved this 7n onto the other side, but it's going to be easier to move the 5n so that we keep this a positive n. So what's going to happen first? Here's our equation, and we've got a larger number of n's, so let's go ahead and subtract our 5n from both sides. Notice we still have a positive 2n. We keep the minus 2 on this side. These canceled out, giving us a 6 alone on that side. Well, of course, remember we need to isolate the variable, so we're going to go back and add the 2 to both sides, which is going to leave us with 2n, and that's going to be equal to 8. And remember, the last part of SID is going to be to do the division. We're going to divide by 2 on both sides so that our n equals 4. Of course, the last thing we are going to do is to check. Now, especially when we've got variables on both sides, we're going to definitely want to check. So let's go back and check. N times, we said n was equal to 4, minus 2 equals 5 times that 4 plus 6. So 28 minus 2, is that equal to 20 plus 6? Yep, 26 is equal to 26. We're good to go. All right, so we solved that correctly. So let's try it again. I've got 4b on this side, and I've got 3b on the other side. So it seems to make a lot of sense to bring this 3b over to this side so we still have a positive number of b's. So subtract the 3b from this side of the equation on both sides, and that's going to leave us with just 1b. You could write 1b, or you can write just b all by itself because we assume that the coefficient is 1 if there's nothing in front of it. We still have that plus 2, and of course now because those cancel each other out, we've got nothing left over here. We've got that 2, so we need to isolate. We need to subtract the 2 from both sides, and that's going to give us b equal to negative 2. 0 minus 2 is negative 2. So b equals negative 2. All right, let's go back and check. 4 times negative 2 plus 2, does that equal 3 times negative 2? Well, I've got negative 8 plus 2. Is that equal to negative 6? Indeed it is. So we're good. Okay, and I'm going to expect to see that check step particularly on your quizzes and on your tests, but definitely practice on your homework so that you're sure that you're getting the solution correct. All right, so we remembered to check. We already did it. So now it's your turn. Try to pause the video and see what you come up with. All right, we subtracted 3x on both sides, leaving us with 2x, and 4 is the only thing left over there. Isolate my variable by getting rid of that negative 2, leaving us 2x equals 6. Divide by 2 both sides. We get x equals 3. Go back in and check. 5 times 3 minus 2, is that equal to 3 times, 3? That wouldn't have worked, would it? Plus 4. So we've got 15 minus 2. Is that equal to 9 plus 4? I've got 13 equals 13, so yes. Okay, hopefully you got that right. So definitely pause the video. Let's see how you do. Okay, I'm going to subtract the 3y this time so that I get 5 equals 4y minus 3. I'm not saying a lot because I assume you've already done this by yourself after you paused. So hopefully you're doing the same work and coming up with the same answers. So 2 equals y or y equals 2. You can have that either way. And go back and check. Five plus 6. Is that equal to 14 minus 3? Yes, 11 equals 11. All right, now, to solve an equation, you may need to first simplify. So remember we talked about SID. So here's the simplify part. All right, so notice what we've got here. Here we've got two like terms we're going to need to combine, and here we're going to need to distribute. So let's go ahead and do that step by step. So I need my pen, and I've got 3x. I'm going to combine my 15 and my 9, so that is plus 6. And then I'm going to distribute my 2 so that I have 2x plus 4. Okay, now this looks like what we had before, and I can go ahead and solve. If you want, pause the slide, see if you got this right. Subtract 2x. I get x plus 6 equals 4. Subtract my 6. So that x equals negative 2. Go back and check. 3 times negative 2 plus 15 minus 9 equals 2 times negative 2 plus 2. So I've got negative 6 plus, I'm going to go ahead and combine 15 minus 9 is a positive 6 equals 2 times 0. So in fact 0 does equal 0. So I'm good. All right, so here you go. Go for it. Definitely pause the slide and come back and check. 4. Combine these two, so I get negative 2a equals negative 1. And remember, I've got to distribute this, so it might be easier to think of it as adding a negative, so that I'm definitely distributing the negative part. So I get minus 35, and I've got a negative and a negative, because remember this is also a negative 2a, so negative 5 times negative 2a is a positive 10a. I want to keep the variable positive if I can, so I'm going to add over here the 2a. I guess I should have combined these over here. Sorry about that. That was negative 36 plus 10a. And I'm going to add the 2a to it. So I had 4 equals negative 36 plus 12a. Add my 36 to both sides. 40 equals 12a. So finally do my D step, and I get, if you don't mind, I'm going to flip it around. So I get a equals, and all I'm going to do is simplify this. I'm going to leave it as an improper fraction, but I definitely have a common multiple, so I'm going to take out my 4. That's going to leave me with 10 over 3. And this is absolutely perfectly fine to leave it as. It's going to be a little complicated to do the check step, but I am going to count on you to do that. So you should pause the slide here and do your check step. Okay, completely on your own. Stop the slide. Stop the video. See what you got. So I'm combining these two over here. I've got 3 minus 3b. And over here I'm going to have to distribute first. So I've got negative 2. Remember, it's plus a negative. So I've got minus 2 and positive 2b. I want to keep my variable positive, so I'm going to go ahead and add 3b to both sides. And again, I should have combined these. That would have been a negative 4. So I've got 3 equals, there was my negative 4 plus 5b. and I'm going to add my 4. So that's 7 equals 5b. Divide now by my 5 to give me b equals 7 over 5. Again, a fairly complex equation to try to do your check step, but I've done it on paper, so you can do it too. If you'd like to see my notes, I'd be happy to share. All right, so after all of these that I've asked you to do on your own, I'm asking you to do this one with me, and I do have a reason behind it. So, of course, I'm going to simplify first. I've got my x and my negative 6x, so I'm going to have a negative 5x, and I still have my plus 4. And on this side, I've got a 6, and remember, I can use the commutative property to move this 2 over here, and that's a negative 2, so I end up with 4 minus 5x. Well, look at that. I've got a negative 5x over here, a negative 5x over here, a positive 4, and a positive 4. I could even go so far as to try to solve this. I'm going to try to isolate my variable by bringing my 5x over. I'm going to add 5x on this side, and look what happens. These are going to cancel each other out, leaving me a 4. These cancel each other out as well, also leaving me a 4. Well, is there ever a time when 4 doesn't equal 4? No, that's going to be all the time, right? So what we have here is an identity. This is an equation that has infinitely many solutions. So if you end up with an equation that looks like this and you solve and find that you have a constant equal to a constant, then you know that you have infinitely many solutions, and the solution set is all real numbers. I could plug in any number for x, and this would give me the same thing on both sides. Any number could be substituted in for x, and I would still end up with this side equal to this side. So this one is called an identity. This is a word that you really should write down. Okay? I've got another trick up my sleeve, so go ahead and follow me through this one, please. And you should be taking notes on this one because this will be a little more, another vocabulary word we're going to be learning. So 12x and x is 13x minus 3. Over here I've got 5 and 8. Oh, look at that. 13x minus 4. That's interesting. So what happens if I go ahead and try to isolate my variable? Well, these canceled out. I got a negative 3. These canceled out. I got a negative 4. Wait, is that ever possible? Could negative 3 be equal to negative 4? Absolutely not. My negative 3 can't be equal to negative 4. So what I have here is a contradiction. There is no value of x that will make this equation true. I could plug in any number I want for x, but there will never be a way to make this equation true. So there are no solutions. Remember in the last slide, any real number would have given us a solution, so we had infinitely many solutions. This time, because it's a contradiction, there are no solutions. All right, so you're on your own to do these. Pause the slide, do these two, see what you come up with. Combining like terms, 3y plus 7 equals 10 plus 3y. And I'm going to isolate, so I'm going to subtract my 3y. Both sides, I imagine some of you are saying, I already see this. There's a contradiction. This can't work. Contradiction. Can't talk and write at the same time. Okay, and let's see that. So there was a contradiction, which means there were no solutions. Let's go ahead and write that out. No solutions. So you should probably have this somewhere in your notes that it's a contradiction and therefore there are no solutions. Okay, and I'm going to do this one too. I've got 3c plus 7 equals, I'm combining like terms over here. Remember, I simplify, so I combine like terms. I get 7 plus 3c, and some of you have already noticed this is exactly the same, but I'm going to go through the process anyway. to isolate the variable. Notice this went away on this side, leaving me a 7, and it disappeared from this side, leaving me a 7. So I have an identity. An identity. That means there are infinitely many solutions, and the solution set is all real numbers. All real numbers. So I have an infinite number of solutions. Okay, so I've got one real world problem that I want you to solve. Okay, so Elizabeth and Rachel are planting tulip bulbs. Elizabeth has already planted 60 bulbs. So she started with 60 and she's planting at a rate of 44 bulbs per hour. Okay, so I'm going to say that X is equal to the number of hours that she's planting these bulbs. Okay, that's the number of hours. But on the other hand, Rachel's already planted 96 bulbs, so she's way ahead of Elizabeth, but she's only planting at a rate of 32 bulbs per hour. So Elizabeth's planting faster, but she got started behind. Rachel got ahead, but is planting slower. So we want to see after how many hours would they have the very same number of bulbs. Well, I'm going to figure that out by setting up an equation. I've got the expression over here. I've got Elizabeth as being 60 bulbs. That's what she started with. And then I've got 44 bulbs per hour. So I know that this is the expression that represents Elizabeth planting. And we want to know when those are going to be equal to each other. So I'm going to set it equal, which is going to mean my X, whatever that ends up being, will be the number of hours that Elizabeth will equal Rachel in terms of the number of bulbs planted. So remember, Rachel now is at 96, and then she's planting at 32 bulbs an hour. So I'm going to solve. There's nothing left to simplify, but I do need to isolate. So I'm going to take my 32x, subtract from both sides. I get 60 plus, this is going to be 12. X is equal to 96. Still need to isolate my variable. So I'm going to take my 60 from both sides, which is going to give me 12x equal to 36. And now I've got the d part of my SID, divide by 12, so that x equals 3. Okay, I definitely want to go back and check this one because I don't know that I'm definitely correct. So I'm going to plug in 3 in my equation. Here's my check step. I've got 60, the original amount planted, plus 44 times 3. So for 3 hours, I'm planting 44 bulbs. That's Elizabeth. Is that equal to Rachel's 96 plus 32 for 3 hours? Okay, well, what do I have? I've got 60. Whoa, this is not looking neat. So sorry about that. 60 plus 132, that's 44 times 3. Is that equal to 96 plus 33? 32 times 3 is also equal to 96. So 60 plus 132 would be 192. And is that equal to 192? Indeed it is. So at 3 hours, so when we plug in 3 for my x, 3 hours, Elizabeth and Rachel will have planted the exact same number of bulbs. Okay, so you've got an online quiz, and we'll see you in class tomorrow.